Hello everyone. So far, in game theory, we have looked at the following points. First, we understood what exactly is game theory all about. We also know its definition. Then we understood certain terminologies which are used in the field of game theory. We also found out what do you mean by maximin and minimax strategy along with saddle point. And then we also landed up solving a couple of problems which gave us the strategies adopted by either of the two players and also the value of the game. Now in this particular video, we are going to have a look at the mixed strategies. That is the games without saddle points. So far, the discussion was on pure strategy, as you know. And just to recap and help you all, pure strategy is when a player or individual chooses one of his two preferences but not mix them. I hope you agree with me. On the other hand, mixed strategy is when individual chooses either of his actions with some probability. For example, choosing to either confess or deny in prisoner's dilemma is a pure strategy. In theory of games, a player is said to use a mixed strategy whenever he or she chooses to randomize over the set of available actions. Formally, a mixed strategy is a probability distribution that assigns to each available action a likelihood of being selected. Whenever I discuss mixed strategy, with the audience community, I always take one of the best example for mixed strategy is the game of cricket. Of course, one of the other reason why I take cricket is also because that is my favorite sports, and I used to play when I was in school and when I was in university days. Uh, I'm not very sure how many of you know that two times I had got the best batsman's award. But leave it apart. The reason why I'm giving you an example of cricket is in cricket, a bowler cannot throw the same type of ball every time because it makes the batsman aware about the type of the ball. I do agree with this. In such a case, the batsman may land up making more runs. However, if the bowler throws the ball differently every time, then it may make the batsman puzzled about the type of the ball he would be getting the next time. Right? So, one of the best example of mixed strategy. But even though I said that if the bowler throws the ball differently every time, it makes the batsman puzzled. But definitely not for some of the dashing batsmen I have seen in this in the world of cricket, like Krishnamachari Srikanth or Vivian Richards. They have this ability to basically blast any type of bowler to any corner of your cricket ground, actually. But that's a different story. Coming back to the mixed strategy, if you watch a professional tennis game, you will notice that players mix their shots all the time. If they always play the same shot, the other player can easily anticipate and position to kill the return shot. Similarly, I feel in poker, players bluff or pretend to bluff by sandbagging a good hand. All of these, and probably many more, are examples of mixed strategies. To be predictable weakens your hand because your opponents can anticipate your actions and position themselves accordingly. The event of surprise has always been in the playbook of sports, war, and business. We all do it at all the time. Surprise requires a mixed strategy almost by definition. So, basically, mixed strategy is nothing but a game without saddle point. I repeat, a game without saddle point. Now, there may be situations when no saddle point exists. In such case, the concept of chance moves or mixed strategies are used. So all game problems where saddle point does not exist are actually considered as mixed strategy problems. Now what do you mean by this? The row minimum is not equal to the column maximum. And you know that When this does not happen, you do not have a saddle point. And what we do is we adopt different methodologies to solve these type of problems. And what is the outcome? The outcome is both players will use different strategies with certain probabilities to optimize. Now, for the solution of games with mixed strategies, any of the following methods can be applied. We have algebraic method, we have arithmetic method, we have graphical method. Now, what is the agenda is we are going to have a look at algebraic and arithmetic method, and then we give a little bit gap and we proceed to look at a different game altogether, which is solved with the help of principles of dominance. And once we are through with principles of dominance, we will come back to graphical method. And that is how we are going to see how games without saddle points, that is mixed strategies, are actually solved. Now let us have a look at the first method, what is called as algebraic method. I'll just run through the points and then we will shift back to our Microsoft Word and I will explain you how to solve the games which involves mixed strategies. So in algebraic method, while applying, it is assumed that x represents the fraction of the time, we call it as frequency as well, for which player A uses strategy 1 and 1 minus x represents the fraction of time for which the player uses strategy 2. Right? So it is basically the concept of probability. If player A uses A1, it is strategy 1 and 1 minus x will represent strategy A2. Similarly, for player B, if y represents fraction of time for strategy 1 and 1 minus y represents the fraction of time for strategy 2. Now let us take an example. For any 2 cross 2 game without saddle point, right? Now assuming the matrix that you have in front of you, which represents the game for 2 players, it is not having a saddle point, right? So I have strategy A1 and A2 for player A, and I have strategy B1 and B2 for player B. And the 4 values in the matrix are called as A11, A12, A21 and A22. Now if this is the situation, now what happens in case of algebraic method of mixed strategy? The optimal strategies, and further down the line we are going to calculate the value of the game, it is given by this particular formula, right? So probability that player A uses A1 is given by the formula. Now let me tell you that you do not have any other option. You have to remember this particular formula. Similarly, you have the probability for which player A uses A2, right? As I said earlier, right, it is nothing but 1 minus x, right? So here x is probability of strategy A1. So once we calculate the strategy, or once we get the strategy of A1, easily we find out the strategy of A2 that is going to be adopted by player A, which is nothing but 1 minus strategy A1. Similarly, I proceed for B, right? So I have strategy for B1 and the probability of B2, which is nothing but 1 minus probability of B1. And once I know the strategies adopted by both the players, I proceed further to find out the value of the game, which is termed as V. And the formula to find the value of the game is there in front of you. Now what we do is we spend some time in trying to understand how to solve these problems using algebraic method. So I have this particular problem in front of me. Solve the following game whose payoff matrix is given, right? So since I am discussing the algebraic method, we will follow this particular method to solve the problem, right? So I have 2 players A and B with A1, A2 strategies for player A and B1, B2 strategy for player B. Now what happens is, let us see how do we solve this particular problem. So first and the foremost thing is, see, unless you do not find out the saddle point, correct, you cannot draw conclusion whether the game is of pure strategy or mixed strategy. So it becomes inevitable for us to find first the saddle point, meaning whether the game has saddle point or not. If the game do not have saddle point, or if saddle point does not exist, only then we go for different methodologies towards mixed strategy, right? So I'm not going to spend more time on finding out the saddle point, which we have done earlier also in the pure strategy. If you look at this, correct, my min max is not equal to max min, and hence this particular game do not have a saddle point. Since it do not have a saddle point, the conclusion drawn is the game is of mixed strategy. So we implement algebraic method to solve this particular problem, right? So I write the values of these four so-called variables. You can say a11 is 6, then a12 is 1, then I have a21 is 4, and then I have a22 is 6. So I'm not going to do anything great. I'm going to substitute it in the value of probability that a uses a1. This is the formula, and hence by substituting the values I get a1 strategy probability as 2 by 7. And then what I do is I just subtract this 2 by 7 by 1, and I land up getting the probability that player A uses A2. So my probability of A2 is 5 by 7, right? So it is just a probability definition. Similarly, by substituting the values for probability that B uses B1, I get B1 is equal to 5 by 7. Just have a look at it. And then I use the same formula, and then I get probability that B uses B2 as 2 by 7, right? So I have A1 as 2 by 7, A2 5 by 7. Similarly, I have B1 5 by 7, and I have B2 as 2 by 7. So A uses mixed strategy 2 by 7 and 5 by 7, and B uses mixed strategy, that is 5 by 7 comma 2 by 7. And then I substitute the values of all these variables and get the value of the game, and the value of this particular game is 32 by 7. So this is the value of the game. So this is how basically algebraic method is used to solve the game theory problems which involves mixed strategy. Let us also have a look at one more example. Let's say this is the example. Solve the following game whose payoff matrix is given. So I have 25, 5, 10, and 15. So as usual, I'll make an attempt to find out the saddle point existence, and then I draw conclusion that this particular problem as well do not exist a saddle point, right? So as usual, I get the values of all this. So my A11 is 25, A12 is 5, A21 is 10, and A22 is 15. And then I get the value of A1 as 1 by 5, and I get the value of A2 as 4 by 5 by substituting the values. And then I proceed for player B. So if player B uses B1 strategy, its value is 2 by 5, and B2 strategy is 3 by 5. So I draw conclusion that player A uses mixed strategy with 1 by 5 and 4 by 5, and player B also uses mixed strategy with 2 by 5 and 3 by 5. And hence the value of this particular game is calculated with the help of the formula, and we draw conclusion that the value of the game is 13, right? So this is how basically we find out the solutions for mixed strategy games using algebraic method. Now once this is done, there is the second method which helps you to solve the problem, what is called as arithmetic method, which is also called as shortcut method or odds method. As such, compared to algebraic method, sometimes people feel that arithmetic method is much more easier, right? But it all depends upon. So this particular method provides an easy way of finding the optimum strategies for each player in a 2x2 game without a saddle point. So it consists of the following steps, right? So just go through the 3 steps that I have written. So these values are called oddments. They are the frequencies with which the players must use their course of actions in their optimum strategies. So what we do is, keeping these 3 points in mind, let us proceed in trying to find out the strategy and the value of the game using arithmetic method. So I go back to my Word file, and then this is my arithmetic method, right? So solve the following game with the help of arithmetic method to find out the strategies and the value of the game. So I have this, right? And I draw conclusion that this particular game also do not have a saddle point, and I use arithmetic method. Now watch out very carefully. What does the arithmetic method says is, the first step is you subtract the two digits in column 1 and write the difference under column 2, ignoring the sign. Okay, so subtract the two digits in column 1, this one, this is the column 1, and write the difference under column 2, ignoring the sign. So this is column 1. What you take? 12 minus 14 is nothing but minus. Ignore the sign and you just write 2. So that is what it says, correct? Subtract the two digits from column 1 and write its difference under column 2. This is the first step. In the second step, what you do? You subtract the two digits of column 2 and write the difference under column 1, again ignoring the sign, right? So 15 minus 10 is 5, so I write 5 here. Got the point? The difference of B1 you write here, that is below B2, and difference of B2 you write here, that is below B1. Got it? Now the same procedure you adopt for row. Now what happens? Now this is my first row with 12 and 15. The difference between that is 3, right? Ignoring the sign, the difference between that is 3. So you write it against the second row. The difference of the first row, you write it against the second row. Similarly, the difference of second row, that is 14 and 10 is 4. You write it against the first row. So I rewrite this particular calculation once again, and then this is how I get it. Watch out carefully. Difference between 12 and 14 is written here. Difference between 15 and 10 is written here. Difference between 12 and 15 is written here. And difference between 14 and 10 is written here. Got it? Now to get the strategy, we add the oddments and place it in the denominator. Watch out carefully. We add the oddments and place it in the denominator. Means what? This is 4 for strategy A1. This is 3 for strategy A2. So what we do is we add these two oddments and place it in the denominator. Means what? This 4 plus 3 is nothing but 7, and hence we place it in the denominator, means we place in the denominator as so that it looks like 4 by 7 and 3 by 7. See, this is what it is. So I say 4 divided by 4 plus 3. Watch out carefully. 4 divided by 4 plus 3. Similarly, 3 divided by 4 plus 3. So I get it as 4 by 7 and 3 by 7. Similarly, if I look at the column, correct? So I say 5, right? 5 divided by 5 plus 2. That is 7. So 5 divided by 7. Similarly, this column is 2. So I say 2 divided by 5 plus 2. So it is 7. So finally, I get like this. 4 by 7, 3 by 7 for player A, 5 by 7 and 2 by 7 for player B. And hence what happens? I write strategies used by both the players. Player A uses mixed strategy with a combination of 4 by 7 and 3 by 7. Similarly, player B uses mixed strategy with a combination of 5 by 7 and 2 by 7. And here I am not doing anything new. I am just going to continue with my algebraic method to find out the value of the game, right? So you are already aware how we find the value of the game through algebraic method, and hence I'm not going to discuss this over here again. We just substitute the values of these A11 up to A22 and get the value of the game as 90 by 7. So this is how you actually land up trying to solve the problem to get the strategies and value of the game using arithmetic method. Let us also look at one more example of arithmetic method. So I have like this. These are my oddments. 8 minus 3, 1. It does not have a saddle point. So it's a game of mixed strategy. And then the difference between 8 and minus 3. is 8 minus of minus 3 is 11. So I write it here. Then minus 3 minus 1 is minus 4. I ignore the sign and I write it here. Then minus 3 minus 1 is minus 4. I ignore the sign. I write it here. That is below column 1. And this is 8 minus of minus 3, which becomes 11. I write it below column 2. And hence my matrix looks like this. So this is 4 and this is 11, right? So this is actually 4, right? So this is 4, this is 4, and this is 11. So let me write it for you. This is 4 and this is 11. This is also 4 and this is 11, right? So this is how I get my oddments, and then I add up and write it as a denominator. So this becomes 4 by 15, this becomes 11 by 15, this is 4 by 15, and this is 11 by 15. And hence what I do, the strategies adopted by player A is 4 by 15 and 11 by 15. Similarly, the strategy adopted by player B is also 4 by 15 and 11 by 15. So I just find out the value of the game, and the value of the game is coming out to be minus 1 by 15, right? So this is how you will end up solving the problems of mixed strategies using algebraic method and arithmetic method.